Hello and welcome to this video on complex number. I think this would be the 27th set of problems. Verify. Yep, 27th set of problems. So without further ado, let's get started. In this set, we will solve problem number 261 to 270. So as always, I will repeat that when I am reading the problem, you should pause the video and try to solve the problem yourself. Only if you cannot solve the problem, only then you should look at the solution. So question 261 says that what region in the Argand plane is represented by the inequality 1 less than mod z minus 3 minus 4i less than 2. So z represents in this case the ring between the concentric circles whose center is at 3, 4i having radii 1 and 2. So it would be like, suppose this is xy coordinate, then center is at 3, 4 and one circle is there of radius 1 and another is with radius 2. The ring formed would be the area represented by this inequality. Question 262 says that find the locus of point z if mod z minus 1 plus mod z plus 1 less than equal to 4. We let z is equal to x plus iy, then mod z square is equal to x square plus y square. Mod z minus 1 square is equal to x minus 1 whole square plus y square. Mod z plus 1 square is equal to x plus 1 whole square plus y square. From given equality, we bring mod z minus 1 to the right hand side and square both sides. We get mod z plus 1 whole square is equal to 16 plus mod z minus 1 whole square minus 8 mod z minus 1. Let me see the problem in quickly. Yep. So the inequality we have converted into an equality for the sake of simplicity. So we solve this by substituting these values. We get 4x is equal to 16 minus 8 mod z minus 1 implies that 4 mod z minus 1 whole square is equal to 4 minus x whole square, which implies 3x square plus 4y square is equal to 12, which is the equation of an ellipse. So you can apply the less than equal to here. You will get the interior of the ellipse as the locus. Question 263 says that if z is equal to t plus 5 plus I square root of 4 minus t square and t is real, find the locus of z. So we let z is equal to x plus iy, then upon comparison of real and imaginary parts, we will have x is equal to t plus 5. That means x minus 5 is equal to t. Y would be square root of 4 minus t square. So y square would be 4 minus t square. We substitute the value of t. We get x minus 5 whole square plus y square is equal to 4, which is a circle with center 5, 0 and radius 2. Question 264 says that if z square by z minus 1 is real, show that the locus of z is a circle with center 1, 0 and radius unity, and the x-axis seems the problem is incomplete. Okay, let's see. Unit radius. Yeah, I think this is extra. There is some typing mistake. Anyway, so we have z is equal to x plus iy. So z square by z minus 1 would be x square minus y square plus 2y xy into x minus 1 minus iy by x minus 1 whole square plus y square. This is rationalized. So since it is real, the z square by z minus 1, we equate the imaginary part to be 0. It will become y into y square minus x square plus 2x square y minus 2xy is equal to 0. That means y is equal to 0 or x square plus y square minus 2x is equal to 0. Okay. So this gives us x minus y whole square plus y square plus 1. But y is not equal to 0. So this condition is not satisfied. Therefore, why y is not equal to 0 is because z won't remain a complex number if y is equal to 0. From here we have x minus 1 whole square plus y square is equal to 1, which represents the circle with center at 1 0 with unit radius. Question 265 says that if mod z square minus 1 is equal to mod z square plus 1, show that locus of z is a straight line. So we take z is equal to x plus iy. Mod z square minus 1 becomes x square minus y square minus 1. There should be something missing here. There is a typing mistake. So mod z square will be x square minus y square plus 2ixy minus 1 will be there. So it will be x square plus y square minus 1 whole square plus 4x square y square is equal to x square plus y square plus 1 whole square. This implies x is equal to 0. So the locus of z is simply the imaginary axis. It is a straight line. Question 266 says that find the locus of the point z if pi by 3 less than equal to argument z less than equal to 3 pi by 2. So from the first condition we have y by x greater than tan pi by 3, that is y greater than square root of 3x. Similarly, there is a dollar missing here. Okay. Similarly, y by x will be less than equal to tan 3 pi by 2, that is minus infinity. So this represents set of straight lines whose slope is greater than square root of 3 and less than equal to minus infinity. Suppose we have x-axis, we have y-axis. Consider this line making angle 60 degree with x-axis. So this angle, you rotate this line, it will cover this much. Okay, it will start in the first quadrant. The line will make angle 60 degree with x-axis. Increase the angle to 90 degree, so it becomes y-axis. And then all the angles which drawn like this, in this way, all these angles. Again, the y-axis will be reversed. All those lines will be the locus of this z. Question 267 says that find the locus of the point z if argument z minus 2 by z plus 2 is equal to pi by 3. So we let z is equal to x plus iy. We are given that argument of z minus 2 by z plus 2 is pi by 3. We substitute and rationalize. We get x square plus y square minus 4 plus 4iy by x plus 2 whole square plus y square. So this essentially is the argument is 4y by x square plus y square minus 4, which is equal to root 3, which is the equation of a circle. Question 268 says that show that the locus of a point z satisfying the condition argument z minus 1 by z plus 1 is equal to pi by 2 is the semicircle above x-axis whose diameter is the join of the points. These shouldn't be joints. Is the join of the points minus 1 comma 0 and 1 comma 0 excluding these points. So we substitute x plus iy and proceed like previous problem. We have 2y by x square plus y square minus 1 is equal to infinity. Now clearly y should be greater than 0. And this implies also x square plus y square minus 1 would be 0, because this has to be infinity. Because tan pi by 2 is infinity. Okay, that means y has to be greater than 0, otherwise 0 by 0 will become an indeterminate form. So this is a circle with center 0 0 and y is greater than 0. That means it is above x-axis. So suppose you have x-axis, y-axis. Circle would be touching the y-axis. Sorry, the center will be origin. So suppose you have xy. So it's a circle with unit radius and center origin. But y has to be greater than 0. So it is only the top part, semicircle. You have to exclude the points minus 1 comma 0 and 1 comma 0 because y is greater than 0. Question 269 says that find the locus of point z if log mod z square minus mod z plus 1 by 2 plus mod z with base root 3 is less than 2. So we take the anti-log, we get mod z square minus mod z plus 1 by 2 plus mod z less than equal to square root of 3 square. This will become 3, which will give us mod z square minus 4 mod z minus 5 less than 0. So that means mod z is greater than 0 and less than 5. From this equation, mod z, one of the roots would be minus 1. Mod z cannot be negative, cannot be -1. Mod z is always greater than 0. This represents interior of a circle having radius of 5. Question 270 says that if O is be the center of the circle circumscribing the equilateral triangle ABC and its radius be unity, A lies on the x-axis, find the complex numbers represented by B and C. So we let so clearly A is 1, 0 or -1, 0. How we have arrived at this is that it's a circumcircle uh, of a triangle ABC equilateral. And O is the origin, okay, and A lies on x-axis, okay. So the circle would cut x-axis and distance from origin to this point A would be equal to radius, but radius is unity. The circle will cut on left side and right side, so it would be either -1, 0 or 1, 0. If A is 1, 0, then Z is cos 0 plus I sin 0. So clearly, since the triangle is equilateral, B would be cos 120, I sin 120. C would be cos 240 degree plus I sin 240 degree. Similarly, B and C you can find when A is -1, 0. That's how we find the complex numbers B and C. With this, we come to the end of 27th set of problems on complex numbers. And I hope that you have been finding this entire series useful and informative, and you are enjoying the series. So thanks a lot for watching. Nice day.